The front-bolted transmission. Look at a tank, and you probably judge it by front armor thickness. Everyone does. They see the M4 Sherman, compare it to German armor, and write it off as a rolling death trap. But real experts look lower down, right at that ugly row of heavy-duty bolts lining the nose. Drop a comment below if you ever notice them, and subscribe right now so you never miss these technical teardowns. This wasn't a makeshift patch. It was a brilliant modular system decades ahead of its time. When a German Panther tank stripped a transmission gear, it instantly became an expensive 50-ton paperweight. To fix it, crews had to erect a massive crane, hoist the multi-ton turret completely off the hull, and tear apart the entire driver's compartment. This took a minimum of 3 to 5 days in a perfect workshop. Under fire, the crew simply blew up their own tank and ran. Now, look at the U.S. Army in the mud of Normandy. When a Sherman's final drive failed, the fix didn't require a rear area depot or a crane. The crew just unbolted the lower nose section right there in the field. The transmission slid out of the front like a heavy dresser drawer. A factory-new module was slung into place, bolted down, and reconnected to the drive shaft. The entire replacement took less than 3 hours under active artillery shelling. Those bolts actually had a secret dual-thread pitch, utilizing the tank's own violent vibrations to lock themselves tighter over time. The Sherman didn't win wars because it was indestructible. It won because it could rise from the dead during the time it takes to change a modern set of brakes. Liberty ship Makerage. World War II wasn't won by engineers building the biggest monster. It was won by mathematicians staring at shipping schedules. In 1942, every single American weapon had to cross 3,000 miles of an ocean infested with U-boats. That meant a ruthless, unyielding constraint for Detroit designers. Your tank must fit inside a strict geometric box. Under 8 feet 7 inches wide and maximum 66,000 pounds. Think that limits a weapon? Think again. Those exact numbers match the lifting capacity of standard boom cranes on Liberty ships. Add just 5 inches of steel to the side armor, and the crane cables would snap, or the tank would jam inside the cargo hold. This precise design allowed a single Liberty ship to pack exactly 36 Shermans inside its belly, maximizing every square inch of space. Once ashore, that same width let the Sherman barrel through narrow, ancient European railway tunnels without stopping. Now look at the German Tiger I, a tactical beast, but an absolute logistical nightmare. Weighing 120,000 pounds and spreading 11 feet 8 inches wide, it couldn't use standard trains. Before rail transport, German crews had to jack up the vehicle, strip off the wide combat tracks, install narrow transport versions, and remove the outer road wheels. The U.S. military weaponized shipping dimensions, outdeploying Germany through unblockable logistical velocity before the first shot was fired. The Parental Powerhouse. Open the engine deck of an M4A4 Sherman, and you will see mechanics born from pure desperation. In 1941, Uncle Sam lacked a heavy tank engine ready for mass production. What do you do when you don't have a massive V12? Chrysler engineers went wild. They grabbed 5 commercial 6-cylinder automobile engines straight from the car assembly lines and geared them together around a single central crankshaft. 30 cylinders, 5 carburetors, 5 water pumps, all jammed into one tight compartment. It looked like a mechanical Frankenstein, but it was practically unkillable. These 5 engines didn't run the tank as one fragile system. They fed power through independent clutches into a central collector. Picture a German 75mm shell ripping through your rear armor, completely obliterating 2 of the outer engine blocks. In any other tank, that's a dead stop. In the Sherman, the driver simply yanked a mechanical lever to uncouple the shattered blocks. The remaining 3 engines kept firing smoothly, producing enough horsepower to keep the 30-ton vehicle moving at 15 miles per hour. It didn't stall out, it didn't leave the crew sitting helpless, and it didn't need a heavy recovery vehicle under fire. While a single shrapnel hit to a Tigers complex Maybach V12 would paralyze the entire machine, the Sherman could lose 40% of its engine bay and still drive itself back to safety. The liquid shield. By 1943, Burning Shermans were a horrifyingly common sight across North Africa. The Germans jokingly called them Tommy Cookers. American crews bitterly dubbed them Ronsons, after the famous lighter that lights first time, every time. The fear of being cooked alive haunted every tanker. Everyone assumed the gasoline engine was the culprit, but military investigators crawled inside the charred steel husks and discovered a different killer. The ammunition storage racks, bolted high on the interior walls directly above the tracks. When a high-velocity anti-tank round punched through the flank armor, white-hot metal fragments sprayed into the unprotected gunpowder casings. The result was an instantaneous, catastrophic internal blowup. Tell us in the comments if you knew ammo caused this, and hit subscribe to join our daily military history briefing. The Pentagon didn't fix this by slapping on tons of heavy armor. Instead, they invented wet stowage, moving the ammo racks down to the lowest point of the floor and encasing them in double-walled jackets filled with a mix of water, glycerine, and anti-corrosive chemicals. Now, say what happens when a German shell hits the ammo grid. The kinetic impact shatters the fluid jackets. Before the friction sparks can ignite the exposed gunpowder, the high-pressure liquid instantly floods the area. This internal liquid barrier slammed the Sherman's catastrophic fire rate from a terrifying 80% down to just 10%, turning a notorious fire trap into the safest tank of World War II to survive an armor penetration. The belly escape hatch. When your tank is hit and catching fire, exiting from the top hatches is often a straight death sentence. Crawling out into the open air exposes your body instantly to enemy machine guns and waiting sniper fire. On a Soviet T-34 or a German Panther, you had no choice but to climb upward into the killing zone. But the Sherman possessed a secret doorway to survival built directly into its heavy floorboards. This life-saving layout was possible because American engineers mounted the tank's suspension entirely on the outside hull. Unlike European designs, the Sherman had 0 torsion bars cutting horizontally across the interior floor space. This left the bottom of the hull completely flat, allowing designers to cut a large emergency escape hatch right underneath the bow gunner's seat. When disaster struck, the crew simply unlatched the heavy floor door and dropped straight down onto the dirt. With 17 inches of ground clearance, the massive steel belly of the Sherman became an impenetrable overhead shield. Tankers could crawl out from underneath the tracks, entirely out of the enemy's line of sight, to fight another day. This simple hatch saved more veteran tankers' lives than thousands of pounds of extra armor plating. It kept crews alive, ensuring experienced soldiers survived the catastrophic loss of their vehicles to fight again. The turret speed advantage. Picture a lethal race at a street corner in Aachen. A Sherman and a Panther round opposite turns, unexpectedly coming face to face. Both of their main guns are pointed 90 degrees in the wrong direction. The clock is ticking, and whoever spins their cannon toward the target first lives. The German gunner slams his foot down on the gas pedal in pure panic. Why? Because the Panther's hydraulic traverse system is tied directly to the main engine's crankshaft. If the German driver isn't roaring the engine at a maximum 3,000 revolutions per minute, the turret moves at a painful crawl, taking up to 60 seconds to make a full circle. Worse yet, if the Panther is parked on a steep 15-degree incline, gravity frequently jams the heavy hydraulic gears completely. The German tank is paralyzed. Meanwhile, the American gunner simply nudges a smooth joystick. The Sherman runs on a dedicated electric hydraulic motor, completely detached from the engine's speed or status. It swings the heavy turret a full 360 degrees in just 15 seconds, even if the main engine is completely turned off or the vehicle is tilted sideways in a muddy ditch. Before the German crew can even complete half their turret rotation, the Sherman's barrel is locked onto the Panther's thin flank armor, firing the decisive shot while the German engine is still desperately revving just to turn the gun. This independent power delivery meant that American tankers routinely outspun their opponents in tight, chaotic urban environments where instantaneous reaction time meant the difference between survival and a catastrophic explosion. they hellfire, he shall. Stop judging the Sherman's 75mm M3 main gun by its ability to pierce thick armor. It couldn't crack a tiger from a distance, sure, but that misses the entire point of combat reality. Armor-to-armor duels accounted for fewer than 15% of all tank engagements across Europe. The remaining 85% of the time, tankers were hunting hidden anti-tank gun crews, clearing machine gun nests, blowing up concrete bunkers, and fighting wave after wave of enemy infantry. For this specific task, the low-velocity 75mm gun was a devastating tool. Its M48 high-explosive shell packed a whopping 47 pounds of pure TNT explosives. The shell wall was engineered with a brittle steel alloy designed to shatter into thousands of razor-sharp fragments, creating a lethal shrapnel radius extending over 40 yards. Now look at the British 17-pounder, the famous high-velocity anti-tank weapon. To survive extreme firing pressures, its shell walls had to be made incredibly thick. This left almost no room inside for explosives, making their high-explosive round a total dud against soft targets that merely chipped concrete without collapsing walls. The Sherman's gun provided American infantry with a rapid-fire mobile artillery piece so destructive that a single shell could vaporize an entire fortified brick firing position. It did the real work of winning the war and clearing enemy strongpoints, while specialized tank killers sat waiting for an enemy armor threat that rarely showed up on the actual front lines. Gyroscopic reflex. Forget the myth that the Sherman could sprint across rough terrain at 25 miles per hour while scoring bullseyes. It couldn't. No sane gunner attempted that because the optics weren't stabilized, meaning the target blurred violently through the sights. Green crews often flipped the single-axis Westinghouse stabilizer off because they didn't know how to calibrate it. But for veterans, this hidden device was a pure lifesaver. The true magic occurred at the exact moment the tank slowed down to shoot. On a conventional vehicle, jamming on the brakes causes the heavy front nose to dip violently on its suspension springs. The main barrel oscillates up and down for 5 to 7 agonizing seconds before settling, leaving the gunner completely helpless. The Westinghouse stabilizer elegantly neutralized this physics problem by applying counterpressure to the gun cradle during deceleration. When a Sherman driver slammed the brakes to engage a threat, the barrel remained perfectly level with the horizon throughout the entire stopping sequence. The gunner required a mere 1 to 2 seconds to refine his sight picture and pull the trigger. By freezing the cannon's vertical movement during sudden stops, this system gave American crews the lethal advantage of the first shot, destroying German tanks while their barrels were still bouncing wildly up and down. This immediate fire response meant that even if a Sherman ran into a heavier enemy vehicle, it could blind or disable the target before the opponent could stabilize their own gun to fire back. The tank infantry phone. A closing hatch strips away a tank's greatest asset, its awareness. Once the crew buttons down all the steel doors to survive sniper fire in a ruined city, their worldview shrinks into tiny glass periscopes with massive 60-degree blind spots. Tankers become utterly blind to a German soldier holding a Panzerfaust-shaped charge weapon just 20 feet away behind a brick wall. Co-located infantry see the danger clearly, but screaming at 2 inches of armor plate is useless. The Americans bypassed this deadly tactical bottleneck with a spectacularly simple piece of field engineering, the tank infantry phone. They bolted a heavy steel box containing a standard EE-8 telephone handset directly to the rear deck of the Sherman, wiring it into the crew's internal intercom system. Now, an infantryman didn't have to risk his life climbing onto the hull. He simply sprinted to the back of the tank, used the vehicle's massive armor mass as a shield against enemy fire, and lifted the receiver. With a single button press, the foot soldier spoke directly into the tank commander's headphones. He could immediately report, "Anti-tank team behind the red wall at your 2 o'clock, blow it away." This direct communication line transformed every infantryman into an extended set of eyes for the armored beast, creating an asymmetric tactical network that stripped away the ambush advantage of hidden German tank killers. This field-expedient innovation bridged the lethal communications gap, allowing iron monsters and foot soldiers to function as a single, unstoppable organism, the Little Joa Auxiliary. Look closer at the subfloor of the Sherman, and you'll find a tiny, hidden advantage that reshaped night combat. This was the Little Joe Auxiliary Generator. German armor doctrine envisioned rapid blitzkrieg operations, completely ignoring the reality of long, freezing nights spent holding defensive ambush positions during an Ardennes winter. To keep the crew warm and power the turret drives, a Tiger tank had to idle its massive, fuel-thirsty Maybach V12 engine. This defensive blunder burned gallons of precious fuel every hour. Worse, it created a loud mechanical roar that could be heard miles away in the dead of night, while emitting a massive heat signature that alerted enemy observers. The Sherman solved this tactical problem with absolute silence. When holding a defensive line at night, the American crew shut down the noisy main engine completely. They turned on Little Joe instead. This tiny single-cylinder motor purred so quietly that it was virtually undetectable beyond 15 feet. It ran on minimal fuel while keeping the batteries fully charged, the radios active, and the internal heaters running to protect the crew from frostbite. A Sherman could sit completely dark and freezing cold on the outside for 12 straight hours, remaining totally invisible to German scouts, while keeping its turret systems hot and ready to swing and fire a lethal shot instantly without ever cranking the main engine. Which hidden feature surprised you most? Tell us in the comments, smash that like button, and subscribe for more raw World War II history. Thanks for watching, and we'll see you on the next battlefield.